Hello everyone, I'm Iswanan Janvidimtinan, and in this video I would like to present my final project step 1, which is clustering for machine learning course. So, first one is problem statement. Because of the time limitation for the problem statement and the data exploration, I will just focus in this report, and then in the modeling I will switch to the source code like here. And okay, for the problem statement, to complete the final project machine learning, of course, and the problem is given to for unsupervised learning is to predict is the customer will interest or not to buy a new vehicle based on the given dataset, which is a kendaraan train.csv. And in this assignment, I will elaborate the step by step in a way doing clustering by using KMeans. And all KMeans implementation is from scratch, not using the library of the KMeans. Okay, first one is we need to import the necessary library. NumPy, PCA, Seaborn Pandas, and etc. As you can see right here. And then for the next, we are going to do a label encoder because as you can see right here, the data, most of the data still has an object right here. It's not numeric. So we need to convert the data. And as you can see right here, we are doing a label encoder. We convert for the non-numeric, jenis kelamin, umur kendaraan rusak. Then we get the category, the category right here. And then we get the final. We get right here is already numeric, float, and integer. So the computer can read it easily. And then for the fill the gap of missing value, there is a missing value right here. The missing value, we drop it. So before we drop it, basically we for the numerical, we fill the gap by fill it with the average, but except for the kode daerah and also kanal penjualan. So for the kode daerah and kanal penjualan with missing value and along with the duplicate data will be removed. And then here we see the variation of the data by using correlation, histogram, and the box plot. So as you can see right here, we see the variance of the value for each features, and there is something odd basically right here for the same. It seems same feature looks like only have one value, but if like we just going in deep into it, basically it has more. It's not only one; it also has a 0. So same features still have a various value, 1 and 0. In this case, we cannot remove or ignore the same feature in dealing with the clustering. And then we see the correlation. Basically, all of the features have a correlation to each other, so we cannot just ignore. That's the reason why I choose to use all the features. And then for the next, we see the box plot for some features. It seems only Umur and Premi who is the one who have the outlier. So in this case, we are going to remove those outlier, and this is the result. We remove the outlier by using 1.5 of IQR, and then in here we are going to see the continuous the probability density by using KDE, kernel density estimate, of the continuous variable for the data that's for the customer who is interested and not interested. So this one is for the who is the one is interest. For the red is the one who is interested, and for the blue is the one who is not interested. It's for the umur, the kernel density estimate, kode daerah, nama pelangganan, premi, kata penjualan. We can see the relation of each continuous feature with the feature tertarik. Here's the reason why myself will take the all features in clustering. And then next we are going to drop the ID column because we still not drop it because the ID is unique, and we need to drop it and remove the duplicates of that. And then we need to scale the data, and in this case we are using standard scaler. The reason is because it removes the mean and scales each feature to unit variance. It's performed feature wise in an independent way. However, it will impact the outliers, but before this one, we already removed the outlier, so it will be fine. Is the result. And then for the next, we have a modeling right here. In this study, I use a K-means algorithm. Yeah, K-means basically have several advantages. It's easy to implement. The time running program is relatively short rather than the others, and easy to explain. And since the concept is relatively simple. And then for this one, I have a class KMeans is the constructor for the class. The author, yeah, myself, I create a KMeans model from scratch, and then this one is we have a fit function, yeah, just to train the to create the KMeans model by using the previous dataset that we have. And then the flow is basically simple. Yeah, to create the centroids as the number of the k. It's we have a function self create centroids, and then do iteration until this one create centroids, and then do iteration until number of the max iteration. So we have a boundary. So if it's still looping and looping, so it will be stopped in 300, and then it will put current centroid to the breadth centroid, so it will be, because we are going to regenerate a new centroid, and then we are going to check is it the current centroid with the previous centroid is equal. If it's equal, so then it will be stopped. It's a basic logic of the K-means. And then we also have this one is function to calculate the SSE, sum square error, this one, inertia. And then for the find the optimal number, yeah, and the next find the optimal number of cluster using the elbow method. This one is basically, yeah, it's the myself serve many arrays such as like, yeah, SSE array, K, target cluster, centralized labels. The purpose is to minimize to regenerate new K-means if we already have a base the optimal K, or we try with another K. And then to prevent human error and reduce the information of humans in deciding which one is the best K or the optimal K, we use the Nilo cutter, as we already import before, library, to decide which one is the best K based on each SSE value. Then this one, and this one, we already got, for this time, we got the best K is 2, and then inverse the label encoding, because we want to see the original data, because we already up to the cluster. And then before we visualize, the data will be transformed back. Yeah, we transform back, and then visualize the data by using histogram for each feature and cluster for K2. Okay, the reason why we use histogram right here is to see the full characteristic of the data in this document. In this document, I will just show the highlight for the histogram, because it's a lot of diagram. So you can see right here. Okay, maybe I will just explain here. It's for the base k equal to this one is for the base k equal to, but it's not satisfy my concern, because I want to see the behavior of the customer. And then I try with the k3. Apparently, it's still not satisfy my concern. I want one cluster that have a huge number of the totaric equal to 1, which is the customer who is interested. And then for this one, still same. I still, yeah, even it has, but it's, yeah, it's still not a huge number. And then I try with the K5, and then I got this one cluster with the totaric is 1. So you can see right here there is some behavior that we can see. For example, is this one kanal penjualan, the 22 until 25 maybe, and 122 until 125. It's probably the most sales of the, yeah, I mean the potential buyer who is maybe interested to buy a new vehicle. And this one is around like 40 years old. Basically, I will highlight it later in the below. And then I also, yeah, this one is for the detail. I also try with another K6 and also, but yeah, it has no any satisfy my concern. And for this one is K7. Basically, K7 have a satisfy my concern, but the reason why I didn't pick this one is because of wait, because it has a two cluster, I think. So it's kind of difficult to define the characteristic, the criteria, yeah. And then this one, the highlight customer characteristic, which are this one, karena penjualan is around this one, never have dealing with the kendaraan rusak, kalau kendaraan is under 1 year, it's not they have no any insurance and etc. And then yeah, it will become the reason why I choose a K equal 5 will be selected and produced for the next step. This one. That's I want to uh, so I want to convert to the export to the CSV. This one. Then I export into this name kendaraan cluster CSV. This one. Yep. And then we just use this one. We jump to the evaluation. K means the evaluation of this part is the optimal K, not always represent good cluster for the user. The best way is to try every K, I think, and see the one who satisfies the user concern or use another unsupervised model in purpose to clustering. And since the all features is used except the ID, and the previous plot is histogram, which means a lot of a diagram to show in this part. Yeah, because I'm a bit confusing if I see this kind of 2D scatter plot, so that's why I use the histogram. In this part, myself I will try to generate the cluster of data, which is in this time is k equal to 5 into 2D scatter by using PCA, principal component analysis. And in this one, we already got this one. Basically myself, the main reason why I choose histogram rather than this one, because I a bit confused to define the characteristic of the customer who is interested to buy a new vehicle. But in this plot, I can see basically this one has a huge number of customers. I mean, it has its own characteristics, so we can define it. And then the conclusion, based on the experiments, the conclusion is every time k-means generated to rerun, the cluster is changed, the base case changed, even the dataset same, and the max k is same. Yeah, I don't know why. Yeah, maybe it's because of the code centroids, it's random. Yeah, I know why. And then, but in this time of experiments, the optimal case not always represent the user concern. The best way is to try every k and as I mentioned before, to until satisfy the user concern or use another model. And then, however, this one, as I mentioned before, is the k into 5, so we got the criteria or characteristic of the user, and by this the clustering fulfill the requirement of the final project step 1 clustering, which to know and get the clustering of the customer will interest or not to buy a new vehicle based on the given dataset. Okay, thank you very much. I think I'm a bit, thank you very much. That's all from me. Thank you very much if you watch until then, and see ya.